You use authentication and authorization every day, even if you have never heard those words. You unlock your phone with your face, that is authentication. You open your banking app and you cannot view another person's account, that is authorization. The words sound similar, but they answer two different questions. Authentication answers, who are you? Authorization answers, what are you allowed to do? There is one rule to remember. Authentication gets you through the front door. Authorization decides which rooms you can enter. Imagine entering an office building. At the entrance, a security guard checks your ID to confirm who you are. That is authentication. Once you are inside, your badge decides which doors you can open. A visitor may only enter the lobby. An employee may also enter the workspace. An administrator may also enter the server room. That is authorization. The first check proves your identity. The second controls your access. This building is a good map for how computer systems work, so we will stay inside it. Authentication means proving that you are who you claim to be. It always has two parts. First, you claim an identity. I am Alex. Second, the system asks you to prove it. The proof you provide is called a credential. A password is a credential. Your fingerprint can be a credential. A security code sent to your phone is also a credential. Credentials matter for a simple reason. Knowing someone's name or email address should not be enough to open their account. You have probably seen a button that says, sign in with Google. Instead of creating another password, the app asks Google to confirm your identity. It works like the guard calling a trusted authority. Google checks who you are and vouches for you. The app trusts Google's answer. This is called federated login. It uses the same idea behind single sign-on, or SSO. One trusted identity helps you access many services. This helps in two ways. You have few passwords to remember, and the app never receives your Google password. Google confirms your identity without handing your secret to anyone. Passwords are useful, but they can be guessed, stolen, or leaked. Imagine someone steals your password. They walk up to the entrance and present it. For important accounts, the system asks for a second kind of proof. This is called multi-factor authentication, or MFA. It combines different types of proof, something you know, like a password, something you have, like your phone, something you are, like your fingerprint. The important part is that the proofs are different types. A thief who has your password probably does not also hold your phone. So the stolen password fails at the second lock. MFA is one of the easiest ways to make an account safer. You would not want to enter your password every time you click a button. So after you sign in, the system gives your device temporary proof that you already passed the identity check. This may be a session identifier stored in a cookie, or it may be a digital token. The technical details differ, but the idea is the same. It works like a temporary badge. As long as the badge is valid, the system remembers that you are signed in. You move from page to page without repeating the check. The badge also expires on its own. And this explains why locking out matters. Locking out invalidates the badge. Another person using the same device cannot simply continue as you. Now the system knows who you are. That does not mean you can do everything. Authorization decides what you can view, create, change, or delete. Each allowed action is called a permission. A teacher may have permission to edit grades. A student may only view their own grades. A child's streaming profile may watch cartoons, but it cannot change the payment settings. So authentication answers, who are you? Authorization answers, are you allowed to do this specific thing? Large systems may have thousands of users and hundreds of permissions. Assigning every permission to every person, one by one, quickly becomes a mess. So systems group permissions into roles. A customer role may view an account, an employee role may update it, an administrator role may delete it. This approach is called role-based access control, or RBAC. Instead of giving John 40 separate permissions, the system gives John the administrator role. The role already contains everything he needs. Roles make access easier to manage and they reduce mistakes. These two ideas also explain two common web errors. A F401 error means you have not successfully authenticated. Your login proof is missing, invalid, or expired. The system is saying, I cannot confirm who you are. A 403 error means you do not have permission. The system knows who you are, but it is saying, you are not allowed to do this. 401 is an identity problem. 403 is an access problem. This is not only for developers. It explains why your bank asks for a security code, why apps request permission before reading your photos, why losing a phone that is still signed in is dangerous, why shared accounts are hard to control, and why every employee in a company should not have administrator access. Authentication protects identity. Authorization limits access. You need both. Good security asks two questions in order. The first question is, do we know this person? The second question is, should this person be allowed to do the specific thing? First authenticate, then authorize. And remember the rule. Authentication gets you through the front door. Authorization decides which rooms you can enter.